Okay, in this video we are doing problem set 57, Calc AB. The problems and a playlist are in the description below, and let's do it. Number 1, use the table of values for the differentiable function f of x to answer the questions. Part A, what is the minimum number of times that f of x equals 0? So if I'm looking for where f of x is 0, I'm thinking this is probably intermediate value theorem. So what I'm going to do is I'm going to look for sign changes. And so, let's see. I need the function to be continuous, so I'm going to say f of x is differentiable, which implies or therefore f of x is continuous. Now I'm allowed to use the intermediate value theorem. So from 4 to 7, there's definitely a sign change. And then from 10 to 13, there's also a sign change. So I'm just going to kind of write down the correct work for that. So I'm going to say, for example, f of 4 is less than 0 is less than f of 7. Therefore, f of x equals 0 for some x between 4 and 7. That's the basic setup for intermediate value theorem. Then I'm going to repeat that process for 10 and 13, but watch out because f of 13 is less than 0 and f of 10 is greater. So you got to make sure you get those in the right order. So f of 13 is less than 0 is less than f of 10. Therefore, f of x equals 0 for some x between 10 and 13. Now we need to finish it off. Why is that got to be true? That has to be true by intermediate value theorem. And then why did we do this? We did this because we're looking for the minimum number of times f of x equals 0. So I will say, therefore, f of x equals 0 has 2 solutions minimum, or has at least 2 solutions. And that's the best we can do in this case. Might have 1,000. We have no way of knowing. All right, next up, approximate f prime of 8. We've done this a lot of times. The only tricky thing is the approximately equal to sign. So do not screw that up. F prime of 8 is approximately equal to. And now we're just going to look at the table. 8 is in between 7 and 9, so we'll find the slope of the secant between those points. So f of 9 minus f of 7 over 9 minus 7. That's the setup for the problem. And then you just, do the calculation. You don't really need to show this part necessarily. You could just jump to the number. But I do want to see that f of 9 minus f of 7 over 9 minus 7 part. That's where you're showing, like, where are the numbers coming from that you're pulling. Even though then you may not show the numbers that you pull. But in your mind, you're pulling them, and I'll understand that. All right. Next, prove f prime of c is equal to negative 2 for some c between 10 and 13. Well, if you look at the table, fortunately, 10 and 13 are like adjacent in the table. They're right next to each other, which means there's no other option. It must be the case that the slope of the secant there is negative 2, because we are definitely, if we're looking at f and proving something, basically if you're proving something about f prime, you can either use IVT on f prime, which almost, I don't want to say never works, but like almost never works. Or you can use mean value theorem, which is a very calculus thing. Use mean value theorem on f of x to say something about f prime. That's what we're going to do here. So to use mean value theorem, I need f to be continuous on the closed interval and differentiable on the open. We're lucky because we're just given that f of x is differentiable. So I'm going to say f of x is differentiable, therefore continuous. That means I'm allowed to use the mean value theorem. So I'm going to say therefore by mean value theorem. And now I'm just going to do it. So f prime of something, f prime of c, is equal to f of 13 minus f of 10 over 13 minus 10, which in this case, I don't know, I'm showing the work. I mean, you could just say is equal to negative 2 if you want, but we get negative 6 divided by 3 is negative 2. And then we'll say for some c between 10 and 13. And that's it. So again, it's possible that maybe you could have used IVT, but we don't actually know that f prime is continuous. We just know that f is differentiable, which means that everywhere that f exists, the derivative exists. Is it possible the derivative doesn't exist somewhere? I don't know. But in this case, even if you tried that, 6 and 8 does not prove that f prime is equal to negative 2, right? Like f prime of 10 is 6, f prime of 13 is 8. There's nothing there that would tell you that f prime is ever negative 2. But mean value theorem, on the other hand, it's like, oh, wow, look at that. Somewhere in there, the slope is negative 2 somehow. All right. D, use a line tangent to the graph of f of x at x equals 9 to approximate f of 8.9. This is like one of the first types of questions that you answer in calculus. So we need the values. So f of 9 is 3, f prime of 9 is 1. The tangent line in point slope form is y minus 3 equals 1, the quantity x minus 9. I write in the 1. Some people don't. I just like to do it like a robot, just like fill in the blanks. Don't worry about what the number is. If it was like x minus 0, I would fill that in. And then we want f of 8.9 to be approximately, so that's where this could still go wrong, f of 8.9 is approximately 3 plus 1 times negative 0.1, which is going to give us 2.9 overall. Technically, on the AP exam, you could leave 3 plus 1 times negative 0.1, and that would be totally fine. And I'd actually probably recommend it because sometimes you accidentally get something wrong that like you just didn't need to get wrong because you didn't need to simplify it. Next question. That's not true in my class, though. You have to simplify everything in my class. It drives me crazy when people don't simplify, but it is a rule on the AP exam, so whatever. All right. Find x of t, the position of a particle, given v of t. Probably should say the velocity, v of t, equals 6t squared plus 4t plus 2, and that x of 1 is negative 5. So we got to go backwards from velocity to position. I'm going to reverse the power rule, right? So there's a 6, and then we'll have a 1/3 t cubed. And there's a 4, and we'll have a 1/2 t squared. So we're doing plus 1 times the reciprocal. Add 1 to the exponent, multiply by the reciprocal of the exponent. And then 2 comes from 2t, right? What has a slope of 2? 2t. And then don't forget, we have to add c because the derivative of a constant is 0. So like any number could have been there. But we actually know something, right? It's not just any number. Let me simplify this first. And then the number actually has to satisfy x of 1 is negative 5. So negative 5 is going to equal, in this case, just 2 plus 2 plus 2, so that's weird, plus c. So that's 6 plus c, subtract 6, you get negative 11, so c is negative 11, which makes overall our function, the position function, 2t cubed plus 2t squared plus 2t minus 11. That's the problem set, and I hope this was helpful, and good luck.